Hi everyone, welcome to lesson 28. The title of this lesson is Special Factoring Formulas. So you might remember in our previous unit when we learned about multiplication and multiplying polynomials, we did have a section on special products. This is kind of the reverse of special products. So you may recognize some of these formulas actually, including what we're starting with right here, perfect square trinomials. So you're seeing some formulas given to you so that you can use them to factor, but just keep in mind you could read them in the other order, in the opposite order, and see them as special products. So I'll just make a note of that. Here, I'll write it down and then I'll read out the formula so you know what we're doing. Okay. Special products, special factoring. Okay, so perfect square trinomials. Here's the first formula. A squared plus 2ab plus b squared equals, parentheses, a plus b, parentheses, squared. So please remember, when you square a binomial, when you start off with a plus b squared, one way you can simplify an expression like that is to write it twice and then FOIL or distribute. When you do that, a plus b squared turns into a squared plus 2ab plus b squared. Let me just kind of do a little side note about that right now before we get too far into these formulas, because we're learning about these formulas, and sometimes in math when we learn formulas, you're not always told why we're using a certain formula or where it comes from. So let me just maybe show you where this formula comes from. So here we are looking at a whiteboard. There's two formulas for perfect squares. One involves a plus sign, one involves a minus sign. I'll just show you the plus sign version. So here's where this comes from. Let's say we're starting off with a plus b squared. This is something that we've seen before, okay? So a plus b squared, you can just write it twice, a plus b times a plus b. Then you can FOIL, meaning you can distribute first, outside, inside, last. So you can do a times a, that's a squared, plus a times b, that's ab, plus b times a, you could write ba, I'm just gonna write ab again, and then finally our last term, b times b, is b squared. So take a look, the two middle terms are alike, ab plus ab, remember there's really ones there in front of the a's, 1ab plus 1ab, there's your 2ab. Okay, so a squared plus 2ab plus b squared. So remember, this was our special product. That was a formula you had learned in our last unit, and I said, hey, you can memorize this or not. Either way, as long as you FOIL, write the parentheses twice and FOIL, you're good. Kind of the same thing here. Rather than doing a special product, now we're going to be doing, we'll just call it a special factoring formula. All right, so just kind of keep in mind the formula we're about to use is related to a special product formula that we've seen before. Okay, let's go back and actually look at our first example. Okay, I was just kind of trying to give you a little bit of background so you could have some idea of where some of these formulas are coming from. Let's take a look at number one. 49x squared plus 28x plus 4. Okay, so we've been factoring trinomials for a couple of lessons now. We've seen different methods. Most recently, we learned about the AC method as well as trial and error. All right, so maybe let's forget about a formula for a second. Let's just do this one using trial and error. In other words, we're just going to do it by kind of doing that FOIL process in reverse. Well, remember, our first terms would need to multiply to this first term in the trinomial, right? 49x squared. So factors of 49x squared, a likely possibility would be 7x times 7x. So I'm putting 7x in the beginning of each set of parentheses. So 7x, then close parentheses, and then 7x close parentheses. I'm leaving those last terms kind of blank for now. Now, if I think about this in terms of FOIL, my last two terms have to multiply to 4. There's a couple of options here. I want you to start noticing perfect squares. That's going to come up a lot in some of these formulas we'll see today. So notice a number like 49, that's really 7 squared. Notice a number like 4, that's really 2 squared. So I'm going to try 2 times 2 as my last two terms. Okay, so in my parentheses right now, I have 7x, then a blank space, then 2, and then in my next parentheses, 7x, blank space, 2. The blank space needs a sign. If you look at this problem, it's all plus sign, so I'll just put a plus here. So we have 7x plus 2 times 7x plus 2. Our answer is going to be 7x plus 2 squared. Okay, now how do I know that that's the answer? I kind of missed an important step here, which is I need to check, right? So to check that this is actually going to work, I need not only the first and the last terms, but I really need to check those outside and inside terms to make sure they add up to what we have in our middle term, which is that 28x, which I've kind of ignored until right now. So I need to check my outside and inside terms. Okay, so let's do that right now. 7x times 2, and then 2 times 7x. So that's 14x plus 14x. Yes, it works. That adds up to 28x. Okay, so that was how you might approach this problem using trial and error or using that FOIL method. You could write your answer as 7x plus 2 times 7x plus 2. Or you could write it as 7x plus 2 squared. All right, but what about the formula? I'm going to erase what I just did and do it again using the formula. All right, so feel free to pause and make sure you have this down, or don't, and just wait until we're doing it with the formula, because that's kind of the whole point here. But I guess when you have these special formulas, use them if you want to, but I just wanted to show you that you can still rely on methods that we've learned before, such as trial and error. Okay, so I'm clearing the slide right now. Let's actually recognize that we can use this perfect square trinomial formula here. All right, so I'm going to write the formula right below our trinomial. So I'm writing a squared plus 2ab plus b squared. Now, the only way a formula can work is if we have a problem that kind of, how do I say this, that kind of lines up with everything. It's in the right form, okay? So is there an a squared at the beginning? Is there something being squared here? Yes, actually. For our first term, 49x squared, that is a perfect square. In fact, we can write it as 7x in parentheses squared. So in a way, it's kind of like a is equal to 7x. Okay, so far we have our first term. We can write it as a squared, 7x squared. That equals 49x squared. What about the last term, b squared? Can I write 4 as something squared? Yes, I can. 4 is equal to 2 squared. So I guess that means that b is equal to 2. Which brings us to our middle term. This is usually the hardest part to recognize here, but let's take a look. My middle term in the formula is 2 times a times b. So I need to check if I do 2 times 7x times 2, meaning I've decided that a is equal to 7x, I've decided that b is equal to 2. If I might multiply those all together, 2 times 7x times 2, do we actually get that middle term of 28x? And we do. 2 times 7x is 14x, times 2 is 28x. So all of that was kind of set up to make sure that, yes, we can use this perfect square trinomial formula. The formula says that when I have a perfect square trinomial like this, I can just factor it as a plus b quantity squared. So a plus b in parentheses squared. A in our problem is 7x, so I'm writing parentheses 7x plus, and then b in this problem is 2. So I can write 7x plus 2 in parentheses squared. Now is the point when you can sort of decide, okay, was that easier than using trial and error or not? Was that worse? Was that more confusing? You may decide which method to use. Okay, it's possible that that was more confusing because it's newer. Okay, so we'll take a look at a few more and see if we can get the hang of recognizing these perfect square trinomials and then trying to factor them using this formula. Let's take a look at number 2. All right, number 2, 9 minus 48c plus 64c squared. Okay, notice that this one does have that minus sign. All right, what else should we notice? I mean, the terms are out of order, so if you would like to rearrange them, you can. You don't necessarily need to, though. I'm going to actually leave the terms like this because, believe it or not, we can still factor it like this. So let's check. Do we have a squared at the front? Do we have something squared equaling 9? Yes, that's 3 squared. Do we have b squared for our last term, 64c squared? Yes, that's a perfect square. That's equal to 8c squared. So now all I have to check is, okay, if a is 3 and b is 8c, if I multiply those together and then multiply by 2, do I get this middle term? So I'm checking, do I have this minus 2ab? Is that going to work here? Let's see. So minus 2 times 3 times 8c. I'm putting a minus sign just to model the actual problem here. That's the only reason. So let's multiply. 2 times 3 is 6. 6 times 8c, yes, that is 48c. Okay, so what I've just done here is make sure that this problem is set up for us to use the formula. So the formula says I can just write my answer as a minus b in parentheses squared. So let's do that, setting up my parentheses, writing my 2 exponent on the outside. The question is just now, what do I put in the parentheses? Well, a minus b. Well, what's a? We decided that a was 3. So I'll start with 3 minus, and we also decided that b was 8c. So we could write parentheses 3 minus 8c parentheses squared. That would be how to work through it using the formula. Or if you're still not sold on using this formula, that's okay. Another way to do it, you could rearrange your terms, putting them in that descending order, and you could still use trial and error. Okay, so I'll quickly show that. I'll use the whiteboard to do that. Okay, so here's what it would look like to rearrange. Let's see. The original problem was 9 minus 48c plus 64c squared. So you could rearrange your terms, put them in descending order. The 64c squared would go first, then minus 48c, and then since that 9 is positive, you'd write plus 9. Maybe that looks better to you, and that's fine. This time, maybe notice that the first term, 64c squared, that could be 8c times 8c, and then the last term, that could be 3 times 3 equals 9. So maybe when I set up my parentheses, 8c times 8c, that would be my first 2 terms, and then 3 and 3 would be my last 2 terms. It's just that I need to make a decision about signs here. 3 times 3 is 9. The 9 is positive, so that means either both of the 3's need to be positive or both of them need to be negative. In this case, they both need to be negative, okay, because of that minus sign that was in the original problem with that minus 48c. So this is another way to write our answer, 8c minus 3 times 8c minus 3, or 8c minus 3 squared. Okay, now you may remember, you may be looking at your paper right now and saying, wait, didn't we get 3 minus 8c squared? Yes, we did. Those terms are switched, which might look like it's a problem, but the thing is, because we're squaring it, any sign differences in here are kind of taken care of. So believe it or not, those are in fact equal to each other because of the squaring that's happening. Okay, so the purpose of that was just to show you an alternative method of doing this problem. Let's go back and we'll see a couple other examples using that perfect square trinomial formula. All right, so all of that was number 1 and 2. Let's look at number 3 and 4 in the next slide. Number 3 is w to the 6th plus 4w to the 3rd plus 4. All right, so w to the 6th. Is this a perfect square? Well, the exponent is a multiple of 2, so that means yes. So this is really equal to w to the third squared, right? See how I'm just kind of dividing that exponent by 2? And then is my last term a perfect square? Yes, it is. 4 is equal to 2 squared. So I can just say a is w to the third, and then my last term b is 2. So let's just check that middle term here. Is that equal to 2ab? 2ab, let's see. 2 times w to the third, and then times 2. Yes, that's equal to 4w to the third. All right, so my trinomial is all set up to go. It is a perfect square trinomial. It does follow that a squared plus 2ab plus b squared setup. So I can factor it as a plus b squared. My a was w to the third plus my b was 2. So our final answer is w to the third plus 2, all in parentheses, squared. Another way I could do it is I could write w to the third plus 2 times w to the third plus 2. I could write it separately if I wanted to, but I'm going to leave it as a perfect square here. All right, number 4, 36v squared minus 84vd plus 49d squared. Okay, I hope when you see the 36, you think about 6 times 6. Okay, so this first term, 36v squared, we can rewrite that as 6v squared. Same with the last term, okay? So 49d squared, we can write that as 7d in parentheses squared. So once again, let's check that middle term. Does it match that formula with 2ab? So 2 times, let's see, making little notes here, a is going to be 6v, so 2 times 6v times our last term, which is 7d. Let's multiply those together. 2 times 6v, that would be 12v. And then 12v times 7d, that is 84vd. Yes, okay, so it looks like we're all set here. This problem does have a minus sign, so a squared minus 2ab plus b squared. We can factor that using a minus b squared. A is 6v, so I'm setting up my final answer, parentheses, 6v minus, and then my b term is 7d. Close the parentheses and square it. Okay, for both of these problems, you could check by writing the parentheses twice and then doing that FOIL process. Okay, so for number 4 that we just did, you could check it by doing parentheses 6v minus 7d, close parentheses, and then parentheses 6v minus 7d. You could FOIL, and you would end up getting the same trinomial in your final answer. All right. So I know that's a lot, and that's only our first set of formulas. I find what we're going to do next to be a little easier. You can decide if you agree or not. So if you're following the formula for perfect square trinomials, if it seems to kind of click for you, that's great. If not, if you're feeling a little lost right now, please know that all of these trinomials can be factored, not with the formula. You can do it in another way. You can use trial and error. You could even use the AC method, both of which were covered in our previous lesson. So you have a choice about which way you do these problems. Do whatever you recognize, do whatever comes most naturally. All right, I'm going to move on. We're going to see some other formulas dealing with perfect squares, and then we'll move into perfect cubes. Okay, so before we move into some other factoring formulas, I have some lists here of perfect squares and perfect cubes. So I have a note here, try to memorize the following lists. It's kind of assumed that you are recognizing perfect squares. So 49, you should know that that's 7 squared, etc. That might not be the case. So now's your chance to make a list. And these lists go on forever, but what I have on the screen is probably more than enough for what you should memorize. Okay, so we'll fill this in together. It's already been started for you. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared, remember, squaring means you're multiplying it by itself. 5 times 5, that's 25. 6 squared is 36. 7 squared, 49. Then 64. Moving on to the next column, 9 squared is 81. 10 squared is 100. 11 squared, 121. 12 squared, 144. This might be around where you're not really sure. I'm going to keep going all the way up to 16 squared, but the list goes on beyond that. But this is probably more than enough for you to memorize. We'll keep going. 13 squared, that's 169. 14 squared, 196. 15 squared is 225. 16 squared is 256. And we're out of room, so I felt like that was good enough. And you can always check on your calculator, but these problems will go so much better for you if you can start to memorize these. So when you see the number 121, I want you to just know that, oh, that's 11 squared. That will be a huge clue for how to proceed. So work on memorizing these if you haven't already. The next list is perfect cubes. These are probably less familiar to you. We are going to see some formulas with an exponent of 3 with perfect cubes. Okay, so the list has been started. 1 cubed, that's 1 times 1 times 1, that's 1. 2 cubed, 2 times 2 times 2, that's 8. 3 cubed is 27. 4 cubed is 64. Let's fill the rest in. 5 cubed is 125. So that's 5 times 5 times 5. 125. 6 cubed, that's 216. 6 times 6 times 6. 7 cubed, 343. 8 cubed is 512. 9 cubed is 729. 10 cubed is 1,000. And again, of course, this list goes on forever. I think you're probably good with this list as it is. You'll especially start to recognize some of those earlier numbers. 8, 27, 64, 125. You'll see those quite a bit when we get to some perfect cube problems. Okay, so keep these lists kind of handy. Refer to them until you don't need to anymore. All right, good. Let's see our next factoring formula. So our next factoring formula is called the difference of two squares. Once again, you should see a connection between this formula and one of our special product formulas that we learned in our previous unit. So you should maybe recognize this pattern when you have a plus b, a minus b. If you multiply those together, you end up getting a squared minus b squared. So if you FOIL those together, you get a squared minus ab plus ab and then minus b squared. Those middle terms cancel out, and that's why we're left with just the a squared minus b squared. So remember, that was a special product that we had seen before. All right. Now, instead of calling it a special product, we're calling it a special factoring formula. So take a look at all the problems on this slide here. All of them have just two terms. So they all start out in this pattern, a squared minus b squared. And the way we will factor each of these problems is using this pattern, a plus b, a minus b. Let's start with number 1, x squared minus 49. So I'm writing the formula right below, a squared minus b squared. Can you tell what a and b are? If a squared is x squared, I guess that means a is just x. And then here's a perfect square, 49. 49 is equal to 7 squared. Okay, so b is 7. So when I factor this, I'm setting up two parentheses. This is really x squared minus 7 squared. So when I factor it, it turns into x plus 7, x minus 7. And that is my factored answer. Okay, so x squared minus 49 gets factored as x plus 7, x minus 7. As always, you can check any of these factoring problems using FOIL or using multiplication. So if we check this one, we would get x squared, and then my outside terms would be minus 7x, and then my inside terms would be plus 7x. They'd cancel out, and then my last terms would be minus 49. Okay, so let's try some more. Let's move on to number 2. 81 minus y squared. Okay, you might be tempted to rearrange the terms, but I'm going to not do that because then it would no longer fit this pattern, okay? If you rearrange the terms, first of all, if you want to just write y squared minus 81, sorry, those are not equal. Okay, so we can't do that. That y squared has to have the minus sign in front of it. If you write minus y squared and then plus 81, that's even less helpful because now there's no formula that will even help us there. So we're going to leave our problem as it is. Recognize that it is a difference of squares. 81 is equal to 9 squared. So we really think of it as 9 squared minus y squared. So it's kind of like a is 9 and b is y. So if I use my formula, a plus b times a minus b, I would just write 9 plus y times 9 minus y. Okay, now just back to the order issue. If you're wondering, can I just write y plus 9, y minus 9? Sorry, no. The y plus 9 part would be okay, but the y minus 9 would be a problem. When it comes to subtraction, we really should not be changing the order. That will change the value of the original problem. So leave these in the order that you see them. Again, 81 minus y squared, we can factor that as 9 plus y and then 9 minus y, because 9 squared is 81 and y squared is y squared. Once again, you could check using FOIL. All right, let's see a few more. Number 3, 16r squared minus 9g squared. Now we have a problem that has more than one variable and more than one number. So let's recognize each of these numbers as a perfect square. 16r squared, that's really the same thing as 4r in parentheses squared. So a is really just 4r minus. Now the 9g squared, recognize that 9 is a perfect square. It's equal to 3 squared. So 9g squared is the same thing as 3g in parentheses squared. So b is really 3g. So set up your parentheses, 2 parentheses. Remember, we're always coming back to this formula, this pattern, a plus b, a minus b. So in this case, it would be 4r plus 3g, and then 4r minus 3g. And that's your answer. Okay, and if you checked it using FOIL, you'd have these outside and inside terms canceling out. You'd get minus 12rg and plus 12rg. And that's why we wouldn't get a trinomial answer with 3 terms. We would just get a binomial answer with 2 terms. Okay, number 4, last one on this slide. 25x to the 4th minus 36. Okay, so let's think about this first term. When you see 25, you should think about that's 5 squared. So I'm going to write 5. Now notice this is x to the 4th. So recognize that this exponent is even. So I do still have a perfect square, but it's not 5x squared. It's 5x squared squared. Sounds strange to say it that way. So 5x squared times 5x squared would be 25x to the 4th. Okay, so in other words, I'm just taking that exponent and dividing it by 2. So a is actually not just equal to 5x, but it's equal to 5x squared here. Meanwhile, you have the minus 36, that's equal to 6 squared. So b is just equal to 6. So if I follow my formula, a plus b, a minus b, here's what that would look like. 5x squared plus 6 times 5x squared minus 6. Oops. Okay. Good. Okay, so those are some examples of the difference of squares. All right, we're going to see a few more. They're about to get just a little bit trickier with some fractions and decimals, but that's okay. Still the same formula. So here's number 5. Kind of continuing the same set, using the same formula. This one is 1/25 minus v squared. Okay. Recognize that we still are dealing with perfect squares. Okay, with fractions, you can kind of look at the parts separately. Look at the numerator and denominator separately. So look at the numerator of 1. That's equal to 1 squared. Look at the denominator of 25. That's equal to 5 squared. So putting it all together, 1/25 is really the same thing as 1/5 or 1/5 squared minus b squared. So when I factor this, a plus b, a minus b, my a is really just 1/5. So it will be 1/5 plus v and then 1/5 minus v. That's it. Okay, so when you see a fraction, plan on checking to see if it's a perfect square, which really means you just get to check on the numerator and then check on the denominator. If both of those numbers are perfect squares, then you're on your way to factoring it. So in this case, 1/25, that's equal to 1/5 squared, which again leads to our answer 1/5 plus v and then 1/5 minus v. Number 6, this one deals with decimals. So use your calculator to help you here. Our problem is 0.81 a squared minus 0.49 c squared. I want you to see that first decimal is 81. Okay, so we know that 9 times 9 is 81. So 0.81 is probably also a perfect square. We need to maybe play around with our decimals on our calculator. If you try different values, what I would try first is just 0.9, and that's what's going to work. So 0.9 squared is equal to 0.9 times 0.9, and yes, that is 0.81. You can use your calculator to help you. Okay, so for this 0.81 a squared, I would rewrite that in parentheses as 0.9 a close parentheses squared minus. For the second term, it's similar, 0.49 c squared. Look at that as 49. Just check on your calculator. If you do 0.7 times 0.7, it is 0.49. So when we rewrite this, it will be 0.7 in parentheses. Let's see, let me say this correctly. Parentheses 0.7 c close parentheses squared. All right, so when I factor this, setting up my parentheses, using that a plus b, a minus b pattern, instead of a, I'm going to write 0.9a for my first term in each parentheses. I'll have a plus sign and a minus sign. Okay, and then my second term, my b is just going to be 0.7c. So I'm filling that in sort of in the second spot in each parentheses. So my final answer is 0.9a plus 0.7c. And then my next parentheses, 0.9a minus 0.7c. Okay, so I know it looks a little more complicated with decimals, but I hope that you could see that the decimals were still pretty much perfect squares, and you might need your calculator to help out a little bit there. Yeah, so 0.81 ended up being 0.9 squared, and then 0.49 ends up being 0.7 squared. All right, number 7. Parentheses, b plus d, close parentheses, squared, minus 64. All right, we're still talking about difference of perfect squares. The formula that we're trying to use here is a squared minus b squared equals a plus b, a minus b. So I'm going to write the formula right below. A squared minus b squared equals a plus b, a minus b. Okay, I hope that you can maybe start to see that in this case, a, it's just the thing in parentheses. So our expression in parentheses, b plus d, that's really just a. So we are going to replace a in our final answer with b plus d. So the answer will look a little bit longer, but try to think of the parentheses expression as sort of one big variable, even though I know it's 2. This is something called substitution. So sometimes when we have expressions in parentheses, we can treat them as one entity or one variable, and we can still apply a formula here. Now 64, I hope that's a little more obvious. 64 is just 8 squared. So our b will be just 8. So let's put it all together. B plus d squared minus 64 can be factored like this. Here we go. Parentheses. Instead of a plus b, we're going to write b plus d plus 8. Close the parentheses. Here's my second parentheses. Instead of a minus b, I'm going to write b plus d minus 8. And that is my long final answer. Okay, so I hope you can see the pattern. It's a little less obvious, but again, instead of a, it's b plus d. And then the plus b and minus b is just the plus 8 and the minus 8. Okay, good. So we've now seen kind of two different kinds of formulas. We saw perfect square trinomials. What we were just working on is the difference of squares, and we were factoring that using a plus b, a minus b. All right, the next slide is just sort of almost like a warning. When you have perfect squares that are, let's see, how do I say this? When you have two terms that are both perfect squares and they're being added, those are not factorable. Okay, so the title of this slide here, it says sum of two squares. A squared plus b squared, those are prime. These, it's almost like a trick question because now you've gotten used to seeing perfect squares. If these problems had minus signs, it would be a different story. But because they have plus signs, that changes everything. So here's the first example, x squared plus 25. It is not x plus 5, x minus 5. It is also not x plus 5, x plus 5. If you distribute, you would not get back to our original problem. If you take x plus 5, x plus 5, you would get x squared plus 10x plus 25. That's different from the original problem, okay? So just be careful when you see two perfect squares being added. That problem cannot be factored. You would just say prime or not factorable. Here's a second example, 16x squared plus 9y squared. If that was a minus, that would be different, but since it's a plus, this problem is prime. Okay. So, just little side note, all you would need to have different is the minus sign. So, if it was x squared minus 25, then you could do x plus 5, x minus 5. Then the difference of squares pattern would apply. Same thing with the 16x squared. If you had 16x squared minus 9y squared, that would be 4x plus 3y, and then 4x minus 3y. But that's not what's being shown to you, okay? So if there's a plus sign between your two perfect squares, you're done. The answer is prime. I think there's one or two like this on your homework. So just kind of be on the lookout. All right, good. So we've done a lot with perfect squares. What we will see next are some formulas that are a little bit different. These next couple of formulas deal with perfect cubes. So remember that list that we made with perfect cube numbers, that will come in handy. All right, these formulas, I will say they're less obvious. Not that the other ones were obvious at all, but they're even less obvious, if at all. They're longer. And quite honestly, when you see these problems, it barely feels like factoring. It just feels like you're plugging into formulas. Okay, so take your time, be patient. These are gonna look a little maybe difficult at first. Just take that all into account. Okay, so here's the first one. This is called the sum of two cubes. A cubed plus b cubed. In other words, a to the third plus b to the third. Here's how you can factor that. Equals. parentheses, a plus b, close the parentheses. And then our next set of parentheses is a squared minus ab plus b squared. Okay, so here's our formula. Let's see if we can apply it to our first problem. K cubed, or k to the third, plus 8. Okay, so k to the third plus 8. I mean, if you didn't have a formula for this, this looks prime. There's no GCF. It's not a trinomial. You can't do grouping. It really feels like there's nothing we can do. But we just have now seen this formula that we can use when we have two perfect cubes being added together. So we have k cubed plus this number 8. If you go back, we'll just go back a little bit here to our list. Let's see if I can find a better way to go back. To our list of perfect cubes. Where was that? There it is. Okay. All right. So take a look at our list of perfect cubes. Look for the number 8 in your list right here. It's the second one in the list. 8 is equal to 2 cubed. We need to keep that in mind for this problem. Okay. So making our way back now. Okay, sorry, I'm sure there was a faster way I could do that. I just didn't want to lose all my writing. All right, so the point of that little detour was just to remind ourselves that 8 is equal to 2 cubed. So we can rewrite our problem as k cubed plus 2 cubed. What this means is a in our formula is just equal to k. And then b is equal to 2, not 8, 2. A common mistake here is to plug in something that's too big. So when you see the number 8, recognize that it's 2 cubed. The thing being cubed is the thing we need to plug in. So a will be replaced with k in our formula. B will be replaced with 2. Once we can figure that out, it's pretty much just a matter of writing out this long formula and then carefully plugging in. And then we're done. So here we go. A plus b, parentheses, a squared minus ab plus b squared. I'm just copying the formula down right now. Now I'm going to replace a with k plus, I'll replace b with 2. So the first part of my answer is k plus 2 in parentheses. Next, I will have this longer trinomial in parentheses. A squared, instead of writing a squared, I will write k squared minus ab. Instead of ab, we need to multiply k times 2. It looks a little strange to write k2. Instead, we write 2k. We're just used to writing the number before the variable. It's kind of the order that we're used to. Okay, plus our last term here, b squared. We're going to get that by doing 2 squared, but we need to simplify 2 squared. Don't just leave 2 squared in your answer. 2 squared is 4. Here it is. So our final answer is k plus 2 times k squared minus 2k plus 4. Okay, so this is kind of strange because the answer is longer than the original problem, isn't it? All right, let's check this. Why does this formula even work? Okay, I'm taking us over to our whiteboard. Let's check. And maybe I'm used to saying check using FOIL. Well, FOIL doesn't really apply because this isn't two binomials. It's a binomial times a trinomial. It's a longer distributing problem. That's okay. We still check using just the distributive property. Okay, so I'm checking k plus 2 times k squared minus 2k plus 4. I'm going to check by distributing. Let's start by distributing the k. K times k squared is k to the third. Next term, k times minus 2k, that would be minus 2k squared. Okay, my third term, k times 4, I will write plus 4k. Okay, so far this doesn't really look like the original problem. That's okay, keep going, because we still have to distribute this plus 2. Okay, so now I do another round, and as you may remember in our previous unit when we were multiplying, I often like to write 2 rows of answers here, so I'm kind of going to line up my like terms rather than writing one long horizontal line. Here we go, so let's distribute the 2. 2 times k, or sorry, say that again. I'm distributing the 2. 2 times k squared, I will write plus 2k squared, and look where I'm writing it, right below the minus 2k squared. Okay, keep going. 2 times minus 2k, that's minus 4k. Finally, 2 times positive 4 is positive 8, so I'm writing plus 8. Now I get to combine like terms, but look at this, the like terms pretty much just cancel out. So let's write out our answer. We're bringing down this k to the third. The minus 2k squared and the plus 2k squared cancel out. The plus 4k and the minus 4k also cancel out, and then that just leaves our plus 8. And that actually does equal our original problem. Okay, once again, the check may be longer than the original problem, but this is a good thing to be able to do at least once so you can kind of prove to yourself that your answer is working. Okay, good. So we're going to go back and we'll see another sum of cubes, then we'll do difference of cubes, and then we'll take a little break. All right, so 27c to the third plus 64. This is our next problem. 27 is equal to 3 cubed. Okay, so this first term, 27c to the third, I'm recognizing that that's equal to 3c in parentheses to the third. In other words, a is equal to 3c when I do my problem. 64, that's equal to 4 to the third, or 4 cubed. So b is equal to 4. Okay, so I'm kind of making a plan here, right? So a is equal to 3c, b is equal to 4. I will use the same formula that we used before, the same formula that's up here at the top. Okay, so a plus b, instead of writing a plus b, I'm going to write 3c plus 4. Next. Okay, I'm going to need to, let's see, I'm going to need to simplify, and so I'm going to do this in a couple of steps. So what I'm writing right now is not going to be the final answer. Instead of writing a squared, I'm going to write 3c in parentheses squared minus. Instead of a times b, I will write in parentheses 3c times 4. And then finally, plus sign, b squared, that's equal to 4 squared. Okay, so my binomial, my first expression in parentheses with 2 terms, that one's all set, 3c plus 4. It's the trinomial, meaning the one with 3 terms, that really needs to be simplified. So let's start with the first term. That 3c squared, that turns into 9c squared. Minus 3c times 4 is 12c. And then finally, plus my last term, 4 squared, that turns into 16. So my final answer for this problem is 3c plus 4 in parentheses, and then my next set of parentheses, 9c squared minus 12c plus 16. I'm not going to go through it again, but you can do a similar check for this problem. You can distribute just like how we distributed in our previous problem. And you should see a lot of terms canceling out. For example, you'll see a minus 36c squared, and then you'll see a plus 36c squared. You'll see a lot of canceling, just like we saw in our previous problem. Okay, good job. We're almost done with this first part of this long lesson here. The last little bit here is going to be a similar formula called the difference of cubes. So we just saw the sum of cubes. We're now going to see the difference of cubes. It's so similar, but there's 2 important differences. First of all, the word difference really refers to subtraction. Okay, so difference of cubes is going to be a cubed minus b cubed. Rather than a plus here, now we have a minus. Take a look at how our signs are different in our formula. Instead of starting with a plus b, now we start with a minus b. Our trinomial is very similar, but yet again, there's a sign change here. Instead of a squared minus, now it's a squared plus ab. And then the last term is always positive. So I'm going to take a moment now to give you a little shortcut that I've used before. You may have seen it if you've seen this before. I'm going to write the word SOAP, S-O-A-P. Here's what this means. I'm going to write S under the first little parentheses, and then O under that plus sign, and then A-P under the last plus sign. This stands for same, opposite, and then always positive. So as you're using these perfect cube formulas, notice that the first sign is always the same as the original problem, so minus in this case. Then the next sign, which is plus in this case, is always opposite. And finally, the last sign is always positive. So you always have that plus b squared at the end. All right, so let's take a look. We have two examples of difference of cubes. So the first one is p cubed minus 343. That might not be a familiar number to you, but if you go back to our list of perfect cubes, you would notice that 7 cubed is equal to 343. So I'm rewriting p cubed minus 7 cubed right below. This means that I will replace a with p in the formula, and I will replace b with 7. Now I'm going to copy down the formula, a minus b, a squared plus ab plus b squared. And then let's fill it in. Instead of a minus b, let's write p minus 7. Then in the second parentheses, instead of a squared, let's write p squared plus a times b is p times 7, but we'll write 7p rather than writing p7. Finally, plus, we have b squared, so we should be doing 7 squared, which is 49. It's important to write plus 49. If you just write plus 7 squared, you haven't fully simplified, and you'll be frustrated getting the problem wrong. Okay, so this is 7 squared, just writing a little note underneath, and then this was p times 7 for that middle term. All right, so p minus 7, and then p squared plus 7p plus 49. That long answer is what we're going for. So we started off with p cubed minus 343, and then we had our final answer. All right, one more using the same formula. The next problem is 125 minus 216w cubed. All right, 125, let's recognize that as 5 cubed minus 216w cubed. Okay, so 216, maybe refer to your list of perfect cubes, that's equal to 6 cubed. Because we have this w here, I'm going to write in parentheses 6w, close parentheses, cubed. So that means I'm going to replace a with 5 and then b with 6w. Using the same formula, my first parentheses, instead of a minus b, let's write 5 minus 6w. And yes, maybe it looks backwards. Remember with subtraction, don't rearrange, okay? So just let it be how it is. Recognize that maybe you want the variable to come first. Sorry, it's coming last, and that's okay. All right, so a was 5, so I started with that, and then b was 6w. So 5 minus 6w. Next, a squared. Instead of writing a squared, let's figure out 5 squared, and that's 25. Okay, plus, instead of AB, I'm going to multiply 5 times 6W, which is 30W for my middle term. Finally, always positive, plus. My last term, that's B squared, so I'm doing 6W squared, which turns into 36W squared. So our final answer is 5 minus 6W in parentheses, and then, new parentheses, 25 plus 30w plus 36w squared. And again, our original problem was 125 minus 216w to the third. And we had to recognize that 125 was 5 cubed and 216 was 6 cubed. Okay, good. So that's probably more than enough for now. We're going to do a part 2. So as I've been saying a lot in this unit, this is where we would take a break. And I think most of our videos right now are in 2 parts. So let's end part 1 right here. Probably after you take a break, go try some of the homework in MyLabs Plus. See what problems you recognize. See if you can start to tell which formulas apply when. And then when you're ready, come back and check out part 2. So the next set of problems that we'll get to, basically it's just building on what we were just doing, seeing some multi-step examples. Okay, so now it's going to be kind of a mixed bag of some problems that are trinomials, some are binomials, some have a GCF, some have perfect squares. It's just going to be all mixed together. So I'll see you soon for part 2. As always, please be in touch. Please ask questions and keep working hard. All right, see you soon. Thanks.